Now, when you're putting that load on, is it trying to maintain the speed of the wheel,
It is,
regardless of the load?
no, this is not closed loop.
No.
Tommy.
What's happening?
What are you demonstrating right now,
Okay,
though?
I'm trying to show the actual eye trip. It's hurting on my fingers. that is not the eye trip. That is the commutation noise. Try to decrease the bitrate.
Tommy, over here. Tommy.
Okay, that is the regulation of the current,
Okay, come on.
right?
Why?
Because we can't see through you.
Yeah, we can't see through you, you're opaque.
So I have a reference voltage that says when
Are you trying to say?
the current flowing through a resistor goes to a voltage that is equal to the voltage that I am putting, I'm going to disable, and shortly after I'm going to enable. If I change, hopefully I can do this.
Tommy, over here.
What is happening?
It's very hard to move my mouse into the left.
Why does he has the blue motor hooked up?
It's moving.
Show people.
We're going to hold the
Is he
motor
gonna
still
show
while you
people how it works in a
rotate.
minute?
It won't chop your hand off.
So he says.
Okay. Okay, so as you can see, I can decrease the current.
Getting stronger.
Tearing Paul's arm off.
Okay, well, I mean, this guy can do up to 30 amps, so if you feel fingers coming out,
Don't worry, I'll let go.
So as you can see, I can control where this current is. The idea is, one, either to limit how much current you want to do, either because, like on a stepper, which is what I designed the board for, on a stepper you just want the current to go to infinity. But if, the other day I just heard of the term, you can let go now. The other day I heard of the term of torque control. I wasn't aware that there are applications in which you actually want to continuously change what the torque is. And this was actually on a, I wasn't sworn to secrecy, so I think I can say that this is used in missiles. The way that they control the fins, they need to at all times know what torque they are exerting on the fins. Maybe because otherwise they will just overshoot, right? If you just let current be whatever it needs to be, and you tell the fin to go, it will just overshoot. And for that kind of fine tuning, they need to say you're going to move like this. And the only way is to control the current.
There'll be similar things on actually, probably on the M1 tank as once they lock onto a target, they have to be able to maintain everything so that no matter what that tank load is, it will maintain.
Yeah, I mean,
Well, what it's kind of about is having your finer control, whereas we often will rely on, let's say, the velocity of our motor, and we're kind of getting a delayed information. If we're looking at our encoder counts, we're getting delayed information, whereas torque is more of an instantaneous input. You know what's going on, and therefore, in fact, I thought when I got started in hobby robotics that I would need that stuff, because when I was doing software for TI years and years ago, and they were doing this real wicked laser plotter, their servo loops definitely had torque loops in them because they were just so finely controlled. But when I got into hobby robotics, we don't need any of that. You just you just go ahead and have your encoders and get your velocity information, and sure enough, it works pretty well, pretty nice. But that's your finer stuff there.
well, I think an example, the only thing I can think of where we'll see this in robotics is, let's say you want a robot to lift a dumbbell, right? If you just let infinite current to flow, the guy's going to start lifting the dumbbell, and as you read the chaff encoders and you adjust the voltage, you're going to go like this, because you're basically trying to control the speed, but in reality what you're trying to control is the strength that you are using to move the dumbbell like this. So if you control the torque, which is basically what you're trying to maintain, is the only application I can think of. If it is a wheel robot, I don't think you need it. But again, other application with a wheel robot that I can think of is, let's say, for battery saving reasons, you just want to use 1 amp, right, continuously, and that gets you going. But if you want to go through a slope, you want to say, now I'm going to let 5 amps flow because I need it to go through that slope. But in reality, with DC motors, as you can see, they will use whatever they need to use. So even if you say, I'm going to limit at 5 amps, and they only need 1 amp, they will use 1 amp. It's whatever they need that they will use.
Dad.
Let's try the PWM. Try the PWM motor here with.
What motor is he gonna test?
The robot motor.
The motor here.
That motor.
Unfortunately, I don't think I can show the 50% duty cycle.
Oh, so you're doing the phase
Yes.
control on
I'm
it?
trying to show you.
What's the PWM frequency?
31.25 kilohertz. 31.25.
Oh, 31.25, okay.
I want to see how
So
the
does it
blue
feel
motor
locked at
works.
the moment?
You can see from here.
You can move it.
Oh, well.
Yeah, because, high frequency, you got an inductor there and you're,
That is the current flowing.
Does that camera come on?
can't move.
Coasting.
Well, you're just switching the polarity
So quick.
voltage across an inductor.
It becomes virtually zero.
The motor's
It's the
not
PWM.
moving, so you get zero current.
No, because of the way you're switching the voltage across an inductor.
Yeah, well, the motor itself never sees it because it's equal. So the motor itself, the concern is zero.
Oh, yeah. Do not look into that projector, Tommy. Bad news. Yeah, that is brighter than sin. It's like, it'll nail
Burn
you.
your cones, man.
Yeah, burn your cones. Or whatever. Rob's
not do
cones.
that.
It is
Something
bright.
Where do you?
All right.
Where do you?
What? Oh, it's mine, whatever, fries.
Fries?
Yeah.
So channel 1 is the PWM. Let's see what duty cycle this is.
Or chewing current to do this, right?
46.80 something.
Not much.
That is 50%, right? Yeah, 50%. So notice that the current is basically centered on 0. That is the current that there's going to be some current flowing, some current flowing out. One way or the other.
Not much, yeah, and it's 0.04 amps. Notice the,
3 minutes? Oh, okay.
yeah.
Hardly. Even
It's
though it's a big honking motor.
basically 120 milliamps positive and 120 milliamps negative. So the motor doesn't move.
Maybe my question was really compared to if you had the motor just disconnected from power, is it the
Then you're not
same?
going to get any current flow.
No. I mean, does the amount of resistance to movement, is that the
okay,
same
yeah. Let me see.
as when
That's what you're
it's
saying.
disconnected from power? When there's no voltage there?
Pretty darn close. Huh?
Actually, there is some resistance.
Oh,
Yes. As you can see.
Yeah, because here
the
you're
current
driving the
changes.
speed to 0. So
Notice that the current moves when I move the wheel because you are
Putting
putting
torque.
energy into
Yeah.
it.
Basically, it's a load, then the motor's moving.
So there is something. See the current?
Yeah, it pushes it.
Mhm.
Yeah.
You see it on the power supply too. Yeah.
Because it's energized and he's moving.
Now,
Yeah,
if you want to feel how, come here and.
Okay, so it is resistant to.
It is.
It will be, because
So
you're
the
you're driving it
faster
to
you try-
zero
yeah.
current. You're driving it to
Right,
zero current,
right.
is what you're doing.
So what you would need to do is if you proportionally, you'd have to start shifting away from 50%.
Yeah, but very light.
If I decide I want to start
But it
spinning
is
it
gonna
this
be more
way,
than if
I
I.
need to start shifting
Turn the
away.
voltage down.